On the model sheet, by selecting cells A2 and A5, the user can select subsets of all data that meet conditions in terms of the risk involved and the respective business unit. This works as a filter. Note that by choosing all risk categories and all units, the example file counts 1,117 events, in cell B9, recorded from March 9, 2015 to March 5, 2020. This generates 223 annual events on average. The model also automatically calculates the average and standard deviation of the recognized net loss for all filtered events. For example, for all 1,117 cases, the average severity or impact of the recognized net loss is $439 and its respective standard deviation is $508. In this case, the standard deviation is even higher than the average, which is very typical in records of operational risk events, that are usually populated by asymmetric severities, as we will see later. If we choose another category, for example, 2.1.2, counterfeiting, leaving for all units, 15 events that occurred in total between August 4, 2015 and October 29, 2019 are obtained, for an average of 3.54 events per year. On the other hand, the mean of each counterfeiting event is $187 and its standard deviation is $95. With the DT Simulator distribution graphs button turned on, it is possible to view respectively, in cells B13 and B14, the frequency and severity distribution of the event that we have selected. We will see this in more detail later. You can also select a category that is not last or third level. For example, when selecting 3.2, Occupational Health and Safety, which is a second-level category, you can observe that the model records 53 events between March 19, 2015 and January 29, 2020, for an annual average of events of 10.88, and a severity of $365, with a standard deviation of $398. Or Level 1, the category for Clients, Products and Business Practices, contains 269 events in the indicated period, generating almost 54 events per year on average, where each of them has a mean impact of $442 and a standard deviation of $575. Take, for example, the very asymmetric nature of these 269 risk events. We can plot these 269 points on a histogram where the y-axis measures how many times a severity is recorded in a given range of data. The vast majority are concentrated to the left side of this histogram. In fact, about 31 registers with the highest frequency, the mode, are events between $100 and $148 each. In other words, many of the events are small time, low impact. However, one or another event, we could count about 10 of them, have a significant amount greater than $1,400 even though the average is around $442. The largest event recorded an impact of $4,780. This begins to communicate to us about the asymmetric nature typically found in operational risk databases. Similarly, the information can be further specified by administrative unit. When selecting Credit Management Unit for the previous category, the model filters 16 events, which means 3.22 events per year, with a mean severity of $541 and a standard deviation of $669. We have now dimensioned, then, the parameters required to construct the magnitude of a risk event. It is enough to select what type of risk, or all risks, and which administrative unit, or all units, you want to filter for this model to calculate three parameters: the average frequency of events per year, the mean and the standard deviation of the severity of the events. Based on these elements, we now proceed to build our convoluted model.